So we're going to go ahead and go into the Pythagorean identities, which comes from Pythagorean theorem. And in fact, we're only going to do one of these for this lesson. We don't really need to worry about the other two. We're just going to be using this one here, which is kind of simple. Later on, we're going to bring these two in, I think in the next chapter. So something we got to, figure out, where does this identity come from? Well, if you remember from the unit circle, let me center it. Should have had this already drawn for you guys. And if we draw our triangle, remember so our radius is 1 because it's the unit circle. Remember, we're sitting on a coordinate plane. That's going to come into play right now. And then we have opposite is going to be the y coordinate. Oops. Adjacent to the x coordinate. So if you just use the Pythagorean theorem, x squared plus y squared equals 1 squared, because it's a right triangle, hypotenuse is 1. So run it through the Pythagorean theorem. X, remember, is cosine, so cosine squared theta plus sine squared theta equals 1, because 1 squared is just 1. And usually they just put sine first, sine squared plus cosine squared. Doesn't matter. We could have just written that as y squared plus x squared instead. Same thing. So it doesn't matter which one's first, the cosine or the sine, or the x or the y. So that's where it comes from. Now here's something you got to pay attention to. Realize that x is negative over here. So if you think of our coordinates, x is negative and y is positive, right? Anything above the x-axis, your y values are positive. So that one's positive, the y value is positive there, the y value is positive here. Just like anything to the right of the y-axis, here's the x coordinates, right? X is positive to the right. So x will be positive to the right. Anything underneath the x-axis, though, as far as y values, the y values are all negative down here. So y will be negative there, and y will be negative there. And then x, since we're to the left over here, since we're to the left of the y-axis, our x values are negative. So that's going to actually come into play in this assignment. Because remember, cosine is x and sine is y. So that's going to change some things, change some of our answers here. So let's go ahead and go right into one of these questions. They're pretty simple. We do have different quadrants and stuff given here. And that's going to come into play. So the angles located in quadrant 1. Why is that important? Because both x and y are both positive in quadrant 1. So our answer should be positive. And you'll see right now why I'm making a big deal out of that. So using our identity, sine squared theta plus cosine squared theta equals 1. We know sine is 11 over 61. I'm going to use Desmos to help me out here. What's 61 squared? I don't know. So it's going to be 121 over 3,721. I'm going to go ahead and change the 1 so it has a common denominator with this. So that's 3,721. Make this look a little nicer. And it's pretty easy dealing with 1, right? Because just 3,721 over 3,721 is equal to 1. So now when we subtract this, it'll be a lot easier. So minus 121 It's 3,600. Now check this out. So how do we get cosine by itself? Because remember, we're trying to figure out what is cosine of theta in this case. So to get cosine by itself, since it's being squared, let's go ahead and square root both sides. Now remember, that's where the plus or minus comes in. So square root of 3,600, I'm pretty sure it's 60. Yep. So we just square root each one individually. Now, do we answer with positive or negative? That's where it matters what quadrant we're in. Since we're in quadrant 1, cosine, which is x, is positive. So we're going to answer with positive. Okay, now we're talking about quadrant 2. So similar problem. We're going to go through it. This one's sine, looking for cosine again. It's the same thing. If you plug it in, on one of these, it gives you cosine, and looking for sine like this one. It runs the same exact way. So we have our Pythagorean identity. So this times sine, well, I guess, again, sine is... Again, we're using sine. So that's 1 over 16. And that's going to be 16 over 16. Might as well change our denominator while we're at it. Subtract 1 over 16. And they don't always work out nicely. In this case, you'll see, square root both sides. And cosine of theta will equal plus or minus the square root of 15. We can't square root 15, so we're just going to leave it as that. And then square root of 16 is 4. Then since we're in quadrant 2, x is negative. Go up there and look, right? Quadrant 2 is on the left side, so x is negative. So cosine's negative. And there you go.